Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to see how we can create our own custom object detection model for TensorFlow Lite on Raspberry Pi 4, Raspbian OS Bullseye 64-bit version. But before we move to our practical friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much and let's get started. So friends, as I mentioned, today we are going to create our own custom object detection model for TensorFlow Lite on Raspbian OS Bullseye 64-bit version. For that, simply first go here in menu programming Thoni. We want to install latest opencv on our Raspbian OS Bullseye 64-bit version. Simply go to the tools, manage packages and search for opencv-python. Just hit enter. It will search opencv-python package, click on it, and I have already installed, that's why it says uninstall. You need to simply click on install button and then it will install opencv-python latest on our Raspberry Pi 4 Raspbian OS 64 version. That's it. Now simply close all these things, and for TensorFlow Lite I have created a repository. I will mention the link. You need to simply copy paste the link inside the browser, then go to the code and click on download zip. It will download our zip format repository. So as you can see, we download our repository. Now simply minimize the browser, go to the file manager, and then we want to go inside our downloads folder. So downloads, and this is what our repository. As you can see, TensorFlow Lite custom model. So right click and click on extract. Here it will extract the folder. So simply right click the folder, cut and move the folder in our home directory. So as you can see, I have moved my folder in home directory. So simply go inside the folder. So first we want to install a TensorFlow Lite. So TensorFlow Lite.sh, this is the bash script. So open terminal. If I run ls command here, and we have our repository. As you can see, this is what our repository, TensorFlow Lite custom model main. So cd TensorFlow Lite custom model -main, run ls command, and this is what our bash script. So we want to give the full permission. So chmod 775, as you can see, chmod space 775, then again space, and mention the file name, the bash file name, which is TensorFlow. So just write te, press tab button, it will automatically complete our bash script name. Just hit enter. Now if you run the ls command, as you can see, the file is basically in green color. It means we successfully changed the permission. Now simply we want to run our bash file. So bash and our file name, bash script name, basically TensorFlow Lite -sh. Hit enter, and now it will download example folder, and inside that example folder we have our setup.sh file, which basically install TensorFlow Lite on our Raspbian OS Bullseye 64-bit version. So first it will download our example folder. As you can see, it's cloning the example folder. So friends, as you can see, we done. So if I run ls command, and here it is what our examples folder, examples. So now simply open the file manager, and inside our repository TensorFlow Lite custom model main, this is what our repository. Inside that we have our example folder. Simply click on it, then go inside Lite folder, then again we have examples folder, and then here we want to search for object detection folder. So here it is, as you can see, we have object detection folder. Then go inside Raspberry Pi folder, and here we have requirements.txt file. So right click and open with the text editor, and here we want to change the opencv version. So by default opencv version is 4.5, so we want to mention here our latest version, which is 4.8.0. so just change the version opencv-python like this way, 4.8.0, simple, and click on file and just save it. That's it, we successfully mentioned the changes. Now just close the file manager, and now we want to change our path from our terminal also. So because we want to install our setup.sh. So right now if I run the command pwd, So we are inside /home/pi, and this is what our repository. So first we want to go inside our example folder. So if I run ls command, here it is, as you can see we have examples folder. So run the command like this way, cd space examples folder, then we have Lite folder, then we have again examples folder, then we have object detection folder, then we have Raspberry Pi folder. So this is the folders which we want to go inside. So first we want to mention the cd command space, mention examples /lite/example/ object detection folder, and then Raspberry Pi folder, and just hit enter. Now if you run pwd command, so we are now inside all this folder, and the main folder is basically Raspberry Pi folder. So just clear the screen. If I run ls command, so here it is, what, as you can see we have our setup.sh file. So this is the bash script for installing TF Lite on our Raspberry OS Bullseye. So run the command bash space setup.sh and just hit enter. It will now install TensorFlow Lite on our Raspberry OS Bullseye 64-bit version. So let's just complete our bash script process, then I will start video again. So friends, as you can see we have completed our setup.sh file process. Now what we want to do, we want to install some packages. So simply again open our repository, which is TensorFlow Lite custom model main, and inside that we have our install.txt, a text file. So open with text editor, and we want to simply copy paste all these three commands. So just first copy it and just paste here and just hit enter. It will install protobuf dependency for TF Lite on Raspberry OS Bullseye. That's it. Now the second command, just copy it and just paste it inside the terminal, just hit enter. It will install TF Lite support. So it's already installed because I have already done with all these steps. Then the last command, so just copy it from the text file and just paste it inside the terminal, just hit enter. It will install TF Lite runtime on our Raspberry OS Bullseye 64-bit version. So as you can see, requirement is already satisfied. That's it. Now we are ready, and we want to first test our default code. So for that, simply close all these things, open menu, programming, Thony. It will open our Thony Python IDE. Then go to the file, click on open. Now we want to go inside our repository. So home, then TensorFlow Lite custom model main, then examples folder, then Lite folder, then again examples folder. Then here we want to search for object detection folder, then Raspberry Pi folder, and this is what our main code, which is detect.py. Just click on it, click on OK, and it will open detect.py. Just close untitled file, and if you scroll down, so by default it will basically start your USB web camera. So I have connected the USB web camera with the Raspberry Pi 4. You can use here Raspberry Pi 4 inbuilt camera also. You need to simply first connect the Raspberry Pi 4 camera module with the Raspberry Pi 4. If you don't know, I have already created the video how to connect Raspberry Pi 4 camera module with the Raspberry Pi 4. But right now I have connect my USB web camera with the Raspberry Pi 4. So here what we want, just scroll down, and here it is. As you can see, the image is equal to cu2.flip. So right now there is no need to flip image. So simply comment this code, image is equal to cu2.flip. That's it. We have done. Now simply run our code. It will start our USB web camera, and it will start TF Lite object detection. And as you can see friends, it detected me as a person. Simple. So it means our TensorFlow Lite is perfectly working. Now we are ready. We have done with our TensorFlow Lite basic installation steps. Now we want to create our own custom object detection model for TensorFlow Lite, and as you can see, it's little bit slow because right now I am recording on same Raspberry Pi 4. Also we started our object detection, so that's why the process is little bit slow. So now we are ready. we want to create our own custom model. So for that, first we need a label EMG software. So again, open our repository, and inside that repository I have mentioned the label emg.txt file. Just click write text editor, and inside that I have mentioned the commands. As you can see, the first command, just copy it, open terminal, clear the screen, and now we don't want to go inside the Raspberry Pi folder, so just run the cd command and come out from our TensorFlow Lite main folder. So now here we want to simply run our pyqt5 dev-tools command. So just copy it from label.emg.txt text file and just paste it, hit enter. It will automatically install our package. Done. Now next package, so open file, text file, and sudo pip3 install label img, copy the command, just paste it, hit enter. That's it, we have done successfully installed label img. Now we are ready. Now we want to create our data set. So for that, we are going to use our USB web camera for creating the data set. So inside our repository, I have mentioned the img.py. So let's just open img.py with the Thony Python IDE. It will basically capture our data images with the help of our USB web camera. So here it is, as you can see. We open our img.py inside our Thony Python IDE. So window size is basically 640480, and the max frames, as you can see, max frames, you can simply increase the max frames. Right now I have mentioned here 30 images, but you can mention 1000 images, you can mention 5000 images. So right now we are going to train only 30 images for each class. We are going to train here two classes. One is basically Raspberry Pi and another one is basically Arduino Uno board. We are going to create a TensorFlow Lite custom object detection model which basically detect our Raspberry Pi 4, also the Arduino Uno board. Simple. So here first we want to create the folder where we want to save our images. So inside our same repository, here I am going to create a new folder which is images. Click on OK, and now we want to simply mention the path. So just right click, copy as a path, and here cv2.imwrite, it will basically write all our images. So we want to mention here our path. So from images, just remove all these things and just press Ctrl+V. It will copy paste our new folder path where we want to save our images. So now the A is basically the image name. So now first we are going to start with Raspberry Pi 4. So just mention here Raspberry Pi, Raspberry, let's say Raspberry-Pi. So this is what our first dataset name. We are going to first capture the Raspberry Pi 30 images with the help of our live USB web camera, and it will save inside our images folder. So now what we want to do, we want to simply take our Raspberry Pi 4 model and we want to move our model in front of our USB web camera. It means it will capture a different angle images and it will save inside our images folder. So now simply save the code and run the code. So friends, as you can see, I move the Raspberry Pi 4 in different angles. So it means we capture a 30 images. So if you open our repository and inside that we create our images folder. So here it is, as you can see, it's captured 30 images and the name is Raspberry Pi, because we mention here our image name is Raspberry Pi and the extension is .jpg. So if you open the image viewer, here it is, as you can see, we capture a different angle images, 29 images for Raspberry Pi. So now same way we are going to change only our object name. So here Now I am going to mention Arduino hyphen Uno. Arduino Uno board, just save it. Now it will capture Arduino Uno 30 images. So friends, as you can see, we have done with Arduino Uno also. So if I open again our repository, this is what our repository, and inside that we have images folder, and now as you can see we have our Arduino board images. So if I open with image viewer, here it is. As you can see we have Arduino Uno 30 images. Also we have Raspberry Pi 4 30 images. Simple, done. Now we want to open all these images with our label EMG software. So just close all this thing, minimize the Tony Python IDE and just open terminal, and here we want to run the command. Let me clear the screen and label IMG. As you can see, you need to simply mention here LAB, just press tab button, it will auto complete the command, just hit enter and it will open our label IMG software. As you can see, it's open our label IMG software. Now simply we want to open dir and we want to go inside our repository where we have our images folder, images, click on choose, and as you can see this is what our images. Again change save dir and same folder which is TensorFlow Lite custom images, we want to save our XML file inside a same folder. Now here we want to select Pascal VOC. Now we are ready. Create rectangle box and draw the rectangle box on our object. So this is what our object, which is Arduino Uno. Mention Arduino hyphen Uno. Click on OK. Save it. Next image, create rectangle box. Draw a rectangle box. Same name, Arduino Uno. Click on OK. Save it. Next image, create rectangle box. Arduino Uno selected. Click on OK. Save it. So this is how you need to draw a rectangle box on each image. So now let me draw a rectangle box on both Arduino and Raspberry Pi 4. Then I will start video again. So friends, as you can see we have done with Arduino Uno board. Now simply we want to select our Raspberry Pi 4 board. So create rectangle box. Again same way we want to draw a rectangle on our Raspberry Pi 4, and here we want to mention Raspberry hyphen pi. Click on OK. Click on save it. Go for next image. Create rectangle box. Draw rectangle box. And Raspberry Pi, this is what our second class. So Arduino hyphen Uno is basically our first class and Raspberry Pi is our second class. Click on OK. Click on save it. Next image, same way. Draw rectangle box. Select Raspberry Pi and click on OK. Now same way I will draw a rectangle box on all Raspberry Pi board images. So friends, as you can see we have done with our image training process. We have successfully completed a drawing rectangle on each object. So simply close the label EMG software and minimize the terminal, and if I open our repository, because inside that repository TensorFlow Lite custom model main we have our images folder, and as you can see the Arduino, their XML file, the Raspberry Pi and their XML file. So we have done with label EMG process. Now we want to simply create a Freedom Tech folder, because in TF Lite Google Colab file I have mentioned the Freedom Tech folder. So simply create a new folder which name is basically Freedom Tech. This is what our folder name, and inside that we want to create a new folder, a two folder, train and validate. So right click, new folder, first one is basically train. Click on OK, then again new folder and validate. Simple, click on OK. So now we have done with creating our folder. Now simply go back, and inside images we have all the images with label. Simply press Ctrl plus A, it will select all the images. right click and copy the images, go back and go inside freedom tech folder, train folder, just paste all the data. Paste it all the images with their labels. Same for invalidate, just paste it. Done. Now we have done with copy paste all our data inside train and validate process. Done. Now simply open the terminal. We want to create here a zip file. We want to create a zip file of our folder. So again cd, we want to go inside our repository, which is TensorFlow Lite custom model main. So cd space, mention our repository name, simply press tensor and just press tab, it will auto complete the folder name, just hit enter. Now if you press here ls, and we have our freedom tech folder. Now open the repository and inside label img.txt file text editor, I have mentioned the command. This is the command. As you can see, it will create our zip file. So just copy the command, copy it, open terminal and just run over here. Just run inside TensorFlow Lite custom model main, because we have here our freedom tech folder and it will create freedom tech.zip file. It will zip all the data which we have inside our freedom tech folder. So just hit enter. As you can see, it's basically create a zip file. So if you open TensorFlow Lite, we have here freedom tech.zip file. Now we want to move this file on our Google Drive. So friends, as you can see, I have opened my Google Drive and here right click and click on file upload, and we want to upload our freedom tech.zip, which is home, then our repository, which is TensorFlow Lite custom model main and freedom tech.zip. Click on open. Now it will upload our file. Meanwhile, I have opened Google Colab and here we want to click on simply upload. So click on upload, click on browse, and we want to go inside our repository where we have our Google Colab file for training our own custom object detection model for TF Lite. So just click on open. It will open our file in our Google Colab. So friends, as you can see, we have successfully opened our file, Google Colab file in our Google Colab machine. So now, because there is some problem with dependency right now on Google Colab, so we are going to create a virtual environment for our creating our own custom object detection model for TensorFlow Lite. Simple. So first we want to simply go in a runtime, then change runtime type and Python 3, select T for GPU, click on save it. Now simply we want to click on connect, it will connect with the GPU. So friends, as you can see, we have successfully connected with our GPU. Now we are going to run our cell one by one. So let's just run our first cell, which basically create a virtual environment. We have done. Now next cell, which basically install our Conda. So friends, here it is. As you can see, on second cell where we are installing our Conda, here it says proceed. Simply we want to mention here Y for yes. So just press Y button from keyboard and just hit enter. So friends, as you can see, we have successfully run our second cell. Now we want to move on our next cell. Just click on it and it will run our next cell. We have done. Now simply Conda create. It will create a environment. The name of our virtual environment is basically my-env and the Python version is basically 3.9. So just click on it. So friends, here in Conda create and my environment Python 3.9, here also we want to mention proceed. Simply mention Y for yes and just hit enter. So So friends, done. We have successfully run our cell. Now we want to move our next cell where we are going to install our TF-Lite-model maker package. So simply run our next cell. So friends, we run our cell successfully. Now next cell, same way, just click on it and it will start the process. So here also we have done, just scroll down, next cell, just click on it. We have done. Now just scroll down, again run next cell. Done. Next cell. Done. Now simply we want to import our Google Drive because we have our data on our Google Drive. So here click on, it will ask you to sign. So connect to Google Drive. Select your Google Drive, means you want to select your Gmail ID where you save your data. Scroll down, click on allow. That's it. We successfully allow to access our data on our Google Colab. So it will basically mount our Google Drive, and here it is. As you can see, we have our freedomtech.zip. Now we want to unzip our data. So just click on next cell. It will unzip our all images with their XML file. As you can see, Arduino-Uno, this is what our first class, and Raspberry Pi is basically our second class. Now we have our data ready. Now simply we want our train.py code, means the Python file which we have inside our repository. So just click on this folder, and here we can simply upload our local file. So just click on and then go inside home. Then this is what our repository, and inside that we have, as you can see, train.py. Just click on it, click on open, and it will upload our file. So warning, just click on OK, and as you can see, we upload our train.py. Now simply just click on, because we want to edit something, it will open train.py over here. As you can see, we open our train.py, and here in train data and in val data we want to mention our classes name. So here it is. As you can see, I have mentioned ESP8266 and Pico in train data, and in valid data also ESP8266 and Pico. So here we want to simply mention our own classes name. So remember one thing, the name here you want to mention same as which we train our images. So Raspberry-Pi. So this is what our second class, and first class is basically Arduino-Uno. So let's just mention as it is, Arduino-Uno. Arduino-Uno, and the next class, which is second class, is basically our Raspberry-Pi. Raspberry, it's not double Y, it's double RY. That's it. Raspberry-Pi and Arduino-Uno. Same here in valid data. Just remove it, ESP8266 and Arduino-Uno, and then here we want to mention Raspberry, just a minute, Raspberry-Pi. That's it. Raspberry-Pi, Arduino-Uno, this is what our class. So this is how you need to mention your classes. So right now we have here two classes. So I have mentioned two classes over here. Arduino-Uno is first class, and second class is basically Raspberry Pi. That's it, we have done. Now simply Ctrl+S, press here. Here it is. As you can see, my cursor is basically inside, mouse cursor is basically inside train.py. Here it is blinking. So here simply press Ctrl+S, close the file, we have done. Now we are ready and we want to start our train.py. So just click on our last shell and it will create our own custom model. So here I have mentioned only 20 epochs. You can simply changes. Let me show you here one more thing. I am going to pause the train. I have paused the training and let me open again train.py. So here in file, let's just scroll down. Let me make like this way, and then we are going to scroll our file train.py, and just here in this line, as you can see, line model is equal to object detector create. In this line, here it is, as you can see, the epochs I have mentioned 20. So we can simply change. So here right now let's just say 100. So it will create 100 epochs. Simple. So again just press Ctrl plus S. It will save and just close train.py, and now just start our training. This is what our last cell. Now it will create our own custom object detection model for TensorFlow Lite. The process is started. And friends, as you can see, the epochs 1 by 100, because we mentioned 100 epochs. So now it will create 100 epochs, and after that we have our own TensorFlow Lite custom object detection model ready. Simple. So meanwhile I will pause video. So friends, we have done with our training session, and here it is. As you can see, we have our model ready, which is base.tf Lite. This is what our custom object detection model for TensorFlow Lite which we create. Simple. So now just click on here and click on download. It will download our base.tf Lite model. So as you can see, it's now downloading, and if we successfully download our base.tf Lite, just go here, click on show in folder, and it will show our model inside download folder. So we want to move our TF Lite model, our custom object detection model, inside our repository examples and Raspberry Pi folder. So just cut it from here, or you can simply copy paste. So let's just copy paste, copy it, go to the home, and we have our repository. Inside that we have our examples folder, then we have Lite folder, then we have again examples folder, then here we want to search for object detection folder. So object detection folder, then Raspberry Pi, and here we want to paste our model. So just paste it. That's it. So now simply we want to again open our detect.py with the help of our Thony Python IDE. So just open Thony, and this is what our img.py. So just close it, because now we have done with our img.py. So we want to open our detect.py. So click on file, click on open, and then it will open our repository TensorFlow Lite custom model main. Go to the examples folder, then Lite folder, then examples again, then here object detection folder. Where is our object detection folder? Here it is, object detection, Raspberry Pi, and detect.py. Click on OK. Simple. So simply scroll down, just scroll down, and here it is. As you can see, on line number 116, this is the by default model. As you can see, this is the by default TF Lite model. So we want to simply copy paste this line, copy it the line, and just paste it here, and make it is in line. Just make it is in line, and this line, which is our by default model, just comment it hash, and here we want to mention our custom model, which is base.tf Lite. So just remove this one and mention here base.tf Lite. That's it. Now it will use our custom model base.tf Lite. So for that we want to comment our by default model. So if you don't want to use your custom model, again simply comment this line and just uncomment default model. So now we want to use our custom model, so just comment by default model and uncomment your custom model. That's it. Save the code, and now we are ready. Simply start our code. It will start our USB web camera. And friends, as you can see, it started our camera. So now if I show the Raspberry Pi 4, so as I mentioned, it's really slow because now I am recording, but as you can see, it's detecting our Raspberry Pi 4 and the accuracy is 0.98 Raspberry Pi. And then if I show Arduino Uno board, and as you can see, Arduino Uno board 95%, accuracy 96. So we successfully create our own custom object detection model. For TF Lite, we detect our custom object, which is Raspberry Pi and Arduino Uno board. So I hope you will learn something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.